Hi all, my name is Adithya and I'm here to present my topic, which is environmental influence on the structural integrity of FRP reinforced geopolymer concrete structures, and here FRP is fiber reinforced polymer. So as we come along, we are gonna hear the topic related to geopolymer concrete and FRP a lot. So the first thing is geopolymer concrete, which is a sustainable alternative to our conventional concrete because of its lower carbon footprint. And geopolymer concrete, as it is very bad because of the brittleness of its nature, and for this, we use fiber reinforced polymer as a composite material to reinforce our geopolymer concrete, which will increase the ductility and brittleness of our geopolymer concrete. So, for this subject, I have gone through main literatures, and some of the key points I got was, first one is the incorporation of these non-metallic fibers such as glass or polypropylene into the geopolymer concrete can increase the ductility and reduce the brittleness. So that was one of the main goal. And the next thing is the effect of fiber reinforced polymer on geopolymer's performance is that the interaction between the compressive strength and the reinforcement ratio. So when there is a difference between the reinforcement ratio, there is difference in the compressive strength too. So the next thing I found out was the fiber reinforced polymer confined significantly enhances the ductility of the geopolymer concrete, but the catch is it mainly under a chloride rich environment. So and significantly the 3-layered carbon fiber reinforced polymer exhibited more pronounced benefits. And one of the other major finding was they found out a prediction system in which the load behavior was calculated correctly, but when it comes to the ductility thing, they failed it. So when all this literature, there were many limitations. So one of the main limitations I found out was the inclusion of environmental factors in this thing. When we are considering an alternative to the concrete, it mainly resides in the environment. So the previous studies failed to address the effect of varying environmental factors such as humidity, temperature, and long-term performance. And the next thing was the sample size and the diversity, because many experiment conducted had limited number of samples, so they didn't have the accurate amount of data so they could brainstorm the result. And to compromise all these things, my research question that I framed as the environmental influence on the structural integrity of FRP on reinforced geopolymer concrete column. So the basic research idea is an experimental research design aimed to isolating effect of different FRP types and configuration on long-term performance of the geopolymer concrete column under varying environmental conditions. The research design was carried out in 25 samples, and the shape was cylindrical columns with a diameter of 640 mm, and there were mainly 4 groups. One group is a conventional concrete, and the other 3 was one with carbon fiber, glass fiber, and the normal FRP. And steel reinforced concrete column were served as control group, and the other 3 was considered as the experimental group. And also environmental conditions were tested under lab conditions which had high humidity and chemical exposure. Even though after the research there were many disadvantages and advantages. One of the advantages was the experiment allowed rigorous analysis of influence of different FRP configuration on geopolymer concrete performance, because we had 3 different types of FRPs, so we could accumulate all the data from all these sets and we could compare them. And the structural data were facilitating for a statistical analysis of the trends between these 3 different type of fibers. And the disadvantage was, even if we considered lab conditions which mimics our environment, we cannot entirely give the conditions that our mother nature gives to these things. And in conclusion, the study investigates the effects of various fiber reinforced polymer types and configuration on geopolymer concrete, revealing its ability to withstand corrosive elements and types of harsh environment. And But the advancement in FRP technology and its integration towards the geopolymer concrete has a great promise and pathway towards more resilient and environmental friendly construction practices. These findings will improve the understanding of the materials and behavior in complex environment and sustainable construction practices, durability and longevity of structures. Thank you.